In section 5.5, we're going to learn a method of integration called integration by substitution. And initially what we're going to look for is the following type of integral. We're looking for an integrand that's a composite multiplied by the derivative of the inner function. So this is the situation that we're looking for in order to apply this method of integration. We have that situation over here, and by the way, u prime of x can be missing a constant in front. So here we have that situation. Our function f would be 1 over square root x to the fourth plus 1, and this is our inner function. The derivative of the inner function is 4x cubed, and there we have the x cubed, we're just missing the 4. Alright, so more or less we have this situation. So what we do, we put u equal to the inner function, then differentiate both sides. For the derivative of u we write du, and for the derivative on the right we write 4x cubed times dx. Now we have an x cubed dx, we're missing the 4, so let's divide by 4 on both sides. So on the left we'll have a 1/4. So 1/2 du is equal to x cubed dx. We're just doing this so that it's easier to substitute into this integral. So now we have x cubed dx is 1/4 du. So we'll immediately replace that with 1/4 du. We can bring the 1/4 out to the outside. Okay, so we replace this, so we're left with 1 over square root, and what's inside there is u, 1 over square root u. So this is our new integral. We can easily change this to the form, to the power form, right? 1 over square root u is u to the minus 1/2, so we can apply the power rule for integration. Alright, so let's do that. U to the minus 1/2, alright, that's add 1 to the exponent, we get u to the 1/2, divide by 1/2, that's multiplication by 2. Alright, now let's just replace u with x to the fourth plus 1. Alright, I'll multiply 2 times 1/4, that's 1/2. And replace u with x to the fourth plus 1. Okay, so that's our solution. That's our antiderivative, or that's our solution. In number 2, again, we're looking for that situation. So here our inner function is cube root x to the fourth. Our outer function is secant squared. And then the derivative of the inner, well, let's just look at that for a second. The inner function is the cube root x to the fourth, changing the square root of x cubed to exponent notation to 1/3. We have that this is equal to all this is actually x to the 4/3 when we change to exponent notation. So what's the derivative of x to the 4/3? Let's just do it over here. Take the derivative, bring down the 4/3. Subtract 3/3 from the exponent, we're left with 1/3. And that's it. Okay. So the reason why we looked at the derivative of the inside is because we wanted to make sure that we had at least this in our integrand, and there it is. We do have it, cube root x. So we have this situation, derivative of inside is on the outside. All right, now let's do our substitution. Let's write u equal to, I'll write this as this inner expression, I'll write it as x to the 4/3 to the 4 over 3. And now we can differentiate. du is 4 over 3 x to the 1/3 dx. Oh, we're ready to substitute now. So for cube root of x dx, let's see, we almost have this here. Let's just multiply by 3/4 on either side. 3/4 du equals, that's the cube root of x dx. So we replace cube root of x dx with 3/4 du. And then we have secant squared u. This is all u, secant squared u. Now remember that secant squared is the derivative of tangent. So this integrand is equal to tangent u. So we have 3/4 tangent u, and now let's switch back to x, and that would be 3/4 tangent of cube root x to the 4th. In number 3, we have that same situation. Here's our inner function, 1 plus 1 over t. And remember that the derivative of 1 over t is minus 1 over t squared. All right, you get that just by differentiating 1 over t, that is t to the minus 1. That's 1 over t. When you take the derivative, just bring down that minus 1 and subtract from the exponent. So we get minus 1 over t squared. All right, so we're going to put u equal to the inner 1 plus 1 over t. And du is minus 1 over t squared dt. We have a 1 over t squared here. The t squared is in the denominator. So let me just multiply both sides by minus 1. Put the minus du equal to 1 over t squared dt. All right, so now we're all ready for our substitution. So for minus du, we will substitute 1 over t squared dx with minus du. All right, so we took care of that and that. And now here we have u to the 10th. So this turns into a simple power rule. And let's just replace u with t. That's 1 plus 1 over t. And that's it. Number 4, we're doing a second type of u substitution. Now the inner function is linear. That means x appears only to the exponent 1. This is linear. So we're doing what we call a linear substitution. All right, so let's try that. Let's put u equal to 2x plus 1. And then differentiate. Du is equal to 2 times dx. Okay, so let's start substituting. So for the square root of 2x plus 1, I'm just going to put square root u. Now here we have du is 2 dx, or 1/2 du is equal to dx. So for dx, we're putting 1/2 du. But what do we substitute for x? Well, we're going to have to solve for x right here. So let's do that. So here we have u minus 1 is equal to 2x. So u minus 1 over 2, that's equal to x. So we're going to replace this x with u minus 1 over 2. Let's take that 1/2 here on the outside. All right, so let's just put it here. Another 1/2 there. And over here I'll write just u minus 1. Okay, let's just rewrite this. So what we have is 1/4. And here we have u minus 1. And instead of square root of u, I'm going to put u to the 1/2 du. Now I want to use the power rule, so I have to multiply through. So let's multiply through here. U times u to the 1/2, that's u to the 3/2, minus u to the 1/2 du. Now we're ready to integrate. Power rule, okay, add 1 to the exponent, add 2 over 2, so we have u to the 5/2. Divide by 5/2, or multiply by 2/5, minus u to the 1/2 plus 2/2, that's u to the 3/2, and divide by 3/2, multiply by 2/3. Okay, and that's our derivative. Now all we have to do is replace u with 2x plus 1, and then we're done. So this is equal to 1/4, 2x plus 1 to the 5/2 times 2/5 minus 2x plus 1 to the 3/2 times 2/3 plus c. Here we have another linear substitution. We'll put u equal to x plus 3. Du is equal to dx. And we have to solve for x as well. So we have u minus 3 is equal to x. So now we're ready to substitute. In the denominator, we just have square root u. Now, dx is equal to du, so here we put just du. And x is equal to u minus 3, so I need to put a u minus 3 right here. So over here we have 2 times u minus 3 plus 1. All right, let's simplify that numerator. That's 2u minus 6 plus 1 over square root u. All right, so we have 2u minus 5 divided by square root u. I'll write that as u to the 1/2. And now in order to use the power rule, I'm going to have to divide this numerator by this denominator. So let's do that. U divided by u to the 1/2 is u to the 1/2. Minus 5, and then just bring this up, u to the minus 1/2 du. So now we're ready for the power rule. Add 1, u to the 1/2 plus 1, that's 3/2, times 2/3, minus 5, u to the minus 1/2 plus 2/2 is 1/2. Divide by 1/2, multiply by 2. And now just replace u here and here by x plus 3. And that would be it. Okay, let's look at this last integral. This is a definite integral from 5 to 17. All right, again, linear substitution. Let's put u equal to x minus 1. Du is dx. So we're going to integrate the square root of u. And dx is equal to du. So here just write du. But remember, this 5 over here, that's an x value, and that 17 also is an x value. So we're going to have to change over to u limits. Okay, so let's do that. So we have when x is equal to 5, just substitute the 5 into here, 5 minus 1, and we have u is equal to 4. So this will be a 4 here. And now when x is equal to 17, u is equal to 16. So that'll be a 16 over here. All right, so don't forget to change your x limits over to u limits. Now we're ready. Integrate. This is u to the 1/2. Add 1. We have u to the 3/2 times 2/3. And we're going to evaluate at 4 and 16. First substituting in 16. 16 to the 3/2 times 2/3 minus 4 to the 3/2 times 2/3. All right, so what do we have here? 16 to the 3/2, 16 to the 1/2, that's the square root of 16 is 4. 4 cubed is 64. So here we have 64 times 2/3 minus, here 4 to the 1/2, that's square root of 4 is 2. 2 cubed is 8. So here we have 8 times 2/3. Okay, so we have 56 times 2/3. And that's 112 divided by 3.